Okay, so this is asking you about odd or even. And so I'm going to define everything first. So the definition of even is, and this is a really confusing definition, so just stay with me for just a second and I'll explain it. The definition of even is f of x is equal to f of negative x. Okay, this is a fancy definition. So I'm going to explain what that means here. So that means if I plug in x, so let's use 1 as an example, right? I plug in 1 and I'm looking at the f of x value. So here it is. This is my y value. So f of x just say y. So here's my value at y. Okay. Or at 1, here it is. Then they say plug in negative x. So I'm going to plug in not 1, but it is his opposite, which is negative 1, and tell me what his value is. I want you to compare those two numbers. If they're the same, then we call them even. If they're the opposite, this is odd, f of x is equal to negative f of negative x. Okay. So I need you to compare this y value to this y value. Are these two equal? Are these two y values equal? Everyone says? Are these two y values equal for this guy and this guy? No. So it's not even. Is everybody okay with that? It's not even. Because these two y values are not the same. In fact, these two y values are what? Opposite. So that means the answer is odd. So wait, say it again, Ms. Johnson. So I need you to plug in a value. Then I need you to plug in his opposite. And if they go up together, like maybe they're on a race and they're going up elevators that are, they're racing up and they hit the same value, then it's considered an even function. If they go in opposite directions, like one takes the elevator down while the other one takes the elevator up in the same number of floors, then it's considered an odd function. Yeah. So someone said, hey, Ms. Johnson, so does that mean a parabola is even? I'll say it like this. A parabola could be even. It doesn't have to be, right? Because what if my parabola looked like this, right? This is not an even function. Why, Ms. Johnson? Because if I go to the right, it's going to be all the way up here. And if I go left, it's right here. These two values, these two y values are not the same. Okay, is everybody okay with that? So for example, if it's not equal, it should be crossed out. If it's not equal and if it's not opposite, then it's neither. Does that make sense? Right? So this is not a binary thing. Binary means it's either this or that, right? So like things that are binary are like, why can't I think of an example right now? Is your phone on or is it off? So your phone could either be on or it is off. There's no in between. There's no like middle ground, right? There's other things that are not binary, like tall and short are not binary, right? Because my tall could be your short, and then there's average, right? So that's more of the case of even and odd. Okay, so let's go up here. Let's look at some examples. Just by looking at this, even, is this even? No, this is not even. How can you tell? Well, because when I go to the right so much, and you can go to the right too if you want. You don't have to do one. If I go to the right 2, it's this little guy. When I go to the left 2, it's not this little guy. So it's not even. Is it odd? Is this odd? Yeah, the answer is no. If I go right 2, and then when I go down, left 2, I don't go down. So this is not. So this is neither. This one, even or odd? Even or odd? Or neither? Even, odd, neither. Yeah, this one's odd. Because if I go over to the right so much, I don't know. I can't go right 1. So if I go right 1 box, which is 0.2, it goes down this much. And if I go left, it's opposite. So right 1, down 3, left 1, up 3. Okay, what about this one? Number 1, even or odd? Neither. Even or odd or neither? Which one? This one's actually a neither. Because look, if you go to the right, you get this much. And if you go to the left, you only get this much. All right, let's do a couple more because there's still a couple people lost a little bit. It says these are 3 even functions. What do you notice about even functions? What would like a little like 3rd or 4th grader say? Yeah, they look the same on each side, right? So yeah, we use the word symmetrical, very good. And we use if you're going to say symmetry, it's almost like the right side is a mirror image of the left side. It's a reflected you can say it's like reflected across the y-axis if that's what you want to say. So yeah, even functions are reflections across the y-axis. Let's go this one. This is not a reflection across the y-axis. You guys said this one was odd. What do you see? How would you describe this one? Does this one have symmetry? So obviously it doesn't have like reflection symmetry, right? Left and right symmetry. Does it have up and down symmetry? Meaning like I can reflect it across the x-axis? So the answer is no. Yes, but you can rotate it. Very good. So this is what we call rotational symmetry. Okay, rotational symmetry means I can spin it and it'll land on itself. Reflection symmetry, or like symmetry across an axis, is called it, like you can reflect it and it'll land on itself. Does that make sense? Here, if I spin this, meaning rotate it, exactly 180 degrees, this will land on itself. So is everybody okay with even, odd things? So you can take letters. Let's just take a couple of letters and let's pretend that's a horrible drawing of an x-axis, x and y axis, and take certain letters. Like look at letter A and like draw it on there so that you can get as much symmetry as you can. And then ask yourself, does it have symmetry? What kind of symmetry does it have? Does it have like across the y-axis? And then there's certain letters that you can do that have rotational symmetry like this. Like clearly the letter W is going to have like the letter W. You see the letter W, the V, the U without the stick. They all have symmetry, right? So very good. Very, very good.